Hello, class. This week we're going to delve into fractions and decimals. We're going to start with fractions and try to just get a general idea of what fractions are. Because typically, the hang up I see for students that have trouble with fractions and decimals is really conceptualizing in general what they even are. So, fractions are just an overall part of a whole, generally speaking. Now we can break pretty much anything in this universe down into as many pieces and parts as we want to. Okay? So if you look at number one here, let's just say this square or this rectangle here represents the universe. If we wanted to, we could break it into halves. Right? We have a pink half and we have a white half. Okay? That pink half would be what we know as one half of that entire universe of that whole. Right? Like I said, we can break anything down. We can break the universe down. We can break a piece of cake down, or a cake itself down. We can break a pizza down, right? We can break a box down. Break a house down. Break a whatever you want to break down into pieces and parts, you can. Okay. The whole idea here is when we're generating these fractions are a part of that whole, and it depends on how many pieces you break it into on what that fraction is. Here we break it into two equally part pieces and we select one of those pieces so we have one half. Okay. Um, the only caveat here is you do have to break them in equal size pieces or equal fractions. Okay. So if we look at number two, instead of breaking this into two pieces, we have broken it into one, two, three, four, five, six, seven, eight. We've broken it into 8 pieces. And out of that 8 pieces, we have selected two. So 2/8 is what we have selected here. Okay, because all we're doing for this this is a very simple worksheet here. It says write the shaded amount as a fraction of the whole amount. We're figuring out what the whole amount actually is, and we're just deciding how many we've actually shaded in. Like I said, we can break anything down into pieces and parts. Okay. Now, what you'll come to find out as you progress through, especially with measurements and stuff, is things are typically broken down into standard size measurements, and then the fractions and pieces of those measurements are broken down in a numeric system. So, if you look at, say, even inches, you can have a tenth of an inch, you can have a quarter of an inch, you can have an eighth of an inch, you can have 3/8 of an inch. So, you pull out a tape measure, it's broken down that way. You can have millimeters, you can have centimeters. Those are broken down into tenths in that particular system. You can have pounds and ounces. That's broken down a certain way. And you can have fractions of each, pieces and parts of each. Okay. So let's go ahead and complete the worksheet. Like I said, hopefully you don't find it too difficult. This is a very, very basic just counting worksheet essentially to figure out what your fractions are. In this number 3, we have 1, 2, 3, 4, 5, 6. We have our entire piece here broken into 6 pieces. That's our denominator of those 6 pieces to our selected. Now, of course, this is getting ready for college math here, so not only do you need to know the fractions, you are going to have to reduce the fractions. And I'll probably cover that a little bit more this week as well. But let's go ahead and hit that. Now, if we look at the first 3 that we've done, 1/2 is as far reduced as it could possibly be. 2/8, on the other hand, we can reduce that fraction. Okay. Now, how do we reduce that fraction? Might be the question you have. What you'll notice here is that 2/8 have both a 2 in common. Okay, 2 can go into 8 and 2 can also go into 2. But visually wise here, if I combined 2 of these blocks, so if I made pairs of 2 here with the blocks, just giving you another way to look at it. If you're given fractions, you're given fractions. Just giving you another way to look at it. If I wanted to, I could essentially make this breakup of 8 pieces into a breakup of 4 pieces that are equally sized. And of those 4 pieces, only one would technically be all the way shaded and selected. Okay. I like to offer a different view. Different people learn different ways. Sometimes a different perspective can help you see it and understand it a little bit better. Okay. So here we went from 2/8 to 1/4. Okay. So mathematically, technically all we did was divide each piece by 2 in order to reduce it. Now, if we go over here, 2 and 6 have both 2 in common too, so mathematically I could just divide both of those by 2, right? So this should reduce to 1/3, which means if I broke this into 3 pieces instead of 6 pieces, one would be completely shaded in, while the other 2 would be blank. See how they're essentially the same thing? 2/6 is the same thing as 1/3. Let's go on to number 4. Number 4 here, we have 4 pieces and they are broken down here, and 2 are shaded. So our fraction here is 2/4. Of course we can, hopefully you can see we can reduce that to 1/2. Number 5, we have, instead of having rectangles here, we have a circle, but we have equally sized little pieces of pie here, so to speak. We can tell that 3 are shaded out of an overall total of 1, 2, 3, 4, 5, 6, 7, 8. So our fraction here is 3/8, and 3/8 cannot be reduced. And number 6, we have, once again, 8 overall slices of pie, and we have 7 total that are shaded in. And once again, that can't be reduced. If I look at number 7 here, number 7, let's see if I can scroll down a bit. Number 7, we have a pie that's broken down into 4 pieces, and one of those are selected. We're just doing fractions. Fractions is essentially a number over another number. That's it. Okay, integer over another integer. That's all it is. Okay, it's just basically a rational number. Okay. All right. Now let's look at 8. Now 8. Back to rectangles here. We have 1 piece shaded. We have 1, 2, 3, 4, 5, 6, 7, 8 pieces overall. So we have an 8. Look at 9. Like I said, hopefully this part goes really, really fast and simple for you. Easy conceptual. You can see it shaded in. You can see the pieces and parts of it that are done. Number 9 is 1, 2, 3, 4, 5 shaded over 6 overall. Okay. Number 10. Hopefully you can see that there's 3 pieces of pie shaded there out of 4 overall. Number 11. You have 3 pieces of pie shaded out of 6. But what goes into both 3 and 6? 3 can. So mathematically I could divide by 3 and reduce this to a half. Or you could see that, hey, I could really just split this into 2 pieces and half of it would be shaded in overall. My drawing's not perfect. Forgive me for that. Number 12, my pie is broken into 3 pieces, and one of those pieces is shaded. Number 13, pie is broken into 6 pieces, and one of those pieces is shaded. 14, once again, 6 pieces. How many are shaded here? 4. Now, might be a little bit more difficult to conceptually see here, but we can reduce this mathematically, right? We can divide by 2, reduce this mathematically. 2 goes into 4 2 times, 2 goes into 6 3 times, it's 2/3. So, if we're thinking visually here, we could break this into 3 separate pieces to reduce it. And only 2 out of 3 pieces are shaded. Kind of see what I did there? Alright, kind of looks exactly like 15 where we do have 3 pieces and 2 are shaded. 2/3. Alright, 16 here. 16, we're going to have, okay, the cool thing about 16 looks a lot like 14 and 15, but it's broken into a different amount of pieces here to it. So here we have 1, 2, 3, 4, 5. Right? And how many pieces do we have total? So we have 1, 2, 3, 4, 5, 6, 7, 8. Now, here's where it looks can be deceiving, because 14, 15, and 16 look very similar in the amount shaded. But is 5/8 the same thing as 2/3 or 4/6? It is not. So some of these fractions and pieces can be very, very close and similar visually to each other, but not necessarily the same thing. That's why it's important to know the mathematical calculations behind them as well, so that you can tell 5/8 definitely doesn't equal 2/3, even though visually they look very close to the same thing. Okay. Number 17. Number 17, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 pieces. 6 of those are shaded. If we wanted to, 2 to mathematically reduce that to 3/4. Okay. And then last but not least on this page, we have 8 of these pieces of pie. And 4 of those are shaded. Or hopefully you can now visually tell that this is basically just split into a half, right? Or you can divide both by 4 and mathematically reduce it. Remember, this is just a little refresher here on what fractions are, because fractions really seem to give people a fit. So we're starting out at the simplest of simple with pictures and shades, right? And here's the answer key so that you can go in and review it. And like I said, they didn't even reduce it in the answer key. They kept it super simple. But if you can't do the very simple stuff, you can't do the very hard stuff. So we start basic, we work our way up. So let's look at the next one. Scrolling on down, it says determine which letter best shows the location of the fraction. Now, here's the deal. Fractions work conceptually about breaking pieces into parts, right? But they also fit on a number line. Yeah, I'm letting that sink in for a minute while I take me a little drink of water. Alright, so we have to be able to locate these pieces on the number line. And on this worksheet, I think it pretty much takes you from 0 to 1. So from none to 1 whole. And we can go past the whole, but we've got to be able to get to the 1 first before we can work on going past it. So let's see what we got. Alright, which letter best shows 1/3? Okay. Now what it shows you here is letters A, B, C, and D. And it does it for each one of the questions. We want to best pick out where 1/3 might be. So we have to kind of mentally know where 1/3 is in comparison to 0, 1/2, and 1. Okay. Now, is 1/3 bigger than 1/2 or smaller than 1/2 is one of the questions you have to ask yourself. And this really throws people for a loop. Okay. Now, I'm going to draw you a little picture. Kind of like what we were dealing with above, right? If I break this into 3 equal size pieces approximately, and I have one of those shaded in, this is 1/3. Okay? This is 1/3. If I have this same size rectangle, but instead broken just into 2 pieces, and one of those is shaded completely in, this is 1/2. So, which one's bigger? Which shaded section's bigger? The half is actually bigger. Okay? Now, I know that's a difficult concept for some people because they're like, it's got a 3 in it. 3 is bigger than 2, so 1/3 should be bigger. That is incorrect. I only have 1 piece out of the 3 total pieces versus I have 1 piece out of the 2 total pieces. Okay? So I had to break my candy bar into 3 pieces and I only get 1. Versus I had to break my candy bar in half and I got to keep 1. So if I only had to break it in half, I'd have a bigger piece than if I had to break it into 3 smaller pieces. Okay? Conceptually here, okay, half's right here in the middle. You can kind of line it up with the picture we have. So B here would probably be the closest one to 1/3. So the answer to A should be B. Okay? Now, the cool thing about this is if we were to, I'm going to erase this, kind of redraw what I just did. So all this really is, if you think about it, the number line is our rectangle that we were initially dealing with. I'm going to do my best to split it up into thirds. And I'm going to draw another one down here and split it up into a half. Just like what I drew over here to the right. Right? If I had a half right here, that's what will be colored in. If I had a third, this is what will be colored in. Which is why we can easily see that B would best represent the 1/3. And that 1/2 is actually bigger than 1/3. Okay? So we're going from visual to putting it on another visual cue, which is a number line, which helps us relate it back to the actual numbers. Let's look at question. 3/3 is the same thing as 1. Okay? We can do a simple mathematical reduction to see that. 3 divided by 3 is 1. Therefore, the answer to B should be D. Alright, let's look at number 2. Which letter best shows a half? Alright, come on, that should be very straightforward. It's got a half written on it. That's B. One right there in the middle. And which letter best shows 2 over 2? 2 over 2 is just 1, which should be D. Which letter best shows 0 out of 6? Now, if I'm fractionalized and I have a 0 in the numerator, which I can do, we don't want a 0 in the denominator, but it's okay to have a 0 in the numerator. If I'm fractionalizing and I've had a 0 in the numerator, 0 over 6 should just reduce to 0. We know 0 is right here at A. So, 3A should just be A. A best represents 0, or 0 over 6. And which letter best shows 6 over 6? Which we can hopefully reduce to 1. Let's see, that's D. Alright, now let's get a little harder. Which letter best shows 1/8? Okay. So if I'm looking at this, where should 1/8 be? Should it be on the right-hand side of a half or the left-hand side of a half? Okay. Now if we're thinking about 1/8, if it helps, just go ahead and draw you a little rectangle. Split it into 8. Means 8 pieces. So 1, 2, 3, 4, 5, 6, 7, 8. So I got 1, 2, 3, 4, 5, 6, 7, 8. I got it split into 8 pieces. I had to color one of those in, and we're always going to start at 0 before we start coloring here. This is what it will look like. So 1/8 should best relate to A. Once again, just representing pictures to the number line so we can choose what best works on that number line. Which letter best represents or best shows 6/8? Okay. In the same way, we can count to 6. 1, 2, 3, 4, 5, 6. That should be D. Okay, because 6 pieces, if I had to color in 6 pieces here, I would have to color from here all the way to here. 6 pieces of that rectangle. Now, which letter best shows 2/6? 2/6. Now, is 2/6 bigger than a half or smaller than a half? Well, what would half of 6 be? Half of 6 is 3. So, half of 6 is 3, which means that 1/2 here is the same thing as 3/6. Right? So where would 2/6 be? 2/6 should be right behind 3/6, which is where B is. How about 1/6? 1/6 should be behind that. 1/6 should be right here where A is. Easy enough. Which letter best shows 5/8? Alright, we got to figure out, is 5/8 on the left of 1/2 or on the right of 1/2? Well, what's half of 8? Half of 8 is 4. So if half of 8 is 4, then 1/2 should be the same thing as 4/8, which means that 5/8 should be on the right-hand side of it. Which means 5/8 should be C. But 2/8 should be on the left of 4/8. Okay. But does that put it at B or A? Now, is 2/8 really close to 4/8? Or a little bit further away than 4/8? That's what you kind of have to ask yourself. Keep in mind that there's a 3/8 between 2/8 and 4/8. So it's probably a little further away, which would lead the best guess to be A right there. Alright. Now, number 7. Which letter best shows 3/4? 3/4. Now, 3 out of 4. 3/4 is definitely bigger than a half, right? Because a half would be 2/4. The next step would be the 3/4, which is probably at C. Which letter best shows 2/4? Well, we just determined that 2/4 is the same thing as a half, so it'd probably be located right there at B. Alright. Which letter best shows 0/6? Which is the same thing as 0, right? Which should be located right there at A. And which letter best shows 6/6? 6/6 is the same as 1, which should be located right there at D. all the answers right there too on your answer key, and you can see on the answer key as well here that it's got them all filled out for you for all the number lines if you wanted to work through the entire number line for all these. Alright, now all we have are marks from 0 to 1. We have to find these locations and mark them. We want to mark the location of 3/3. Well, if you can notice, it's already pre-marked for you on the number line in thirds because it goes 1, 2, 3. Okay, so in this case, 3/3 is right here. 3 out of 3, which is the same as 1. Number 2 wants us to mark the location of 1/3. So here I've got it split up. You always need to count and make sure the lines are split correctly because sometimes they won't be. But in this case, I have 1, 2, 3. 3 lines that's broken into thirds. So 1/3 would just be one of those lines over. Alright. Number 3, we want to mark the location of 1/7. Let's make sure it's broken into sevenths. 1, 2, 3, 4, 5, 6, 7. Okay, it is. So that 1/7 would be right here. Okay. And it does say mark them, so I'm not sure if I even put a dot right here on here. Probably should. Okay. Alright, let's mark the location now on this next one of 0/7. Okay. 0/7 is the same thing as 0, which is going to be right there. 5 wants us to mark the locations of 5/8. Let's make sure it's broken into 8. 1, 2, 3, 4, 5, 6, 7, 8. It is. There's 8 ticks between 0 and 1. Alright, so we want to mark 5/8. So we need to count to 5. 1, 2, 3, 4, 5. This one right here should be 5/8. Number 6, we want to mark the location of 3/4. We got 1, 2, 3, 4. Okay, the 1 would be the 4 out of 4, obviously. We need to go 3 over. So this is 3/4. Be right there. Number 7, we want to mark the location of 4/8. So here it's broken into 8. You can count it if you want to. 1, 2, 3, 4, 5, 6, 7, 8. Yep, broken into 8, no problem. This is the 4th one. So this is our 4/8. Mark the location of 2/7. 1, 2. There are 7 total. 3, 4, 5, 6, 7. So 2/7 is here. It's really just counting, locating it on the number line. Marking the location now of 1/5. 1/5 right there. Location of 2 out of 2. 1, 2. 2 out of 2 is the same thing as 1. You can see that it reduces to that, no problem. A few of these left. Marking the location of 5/7. 1, 2, 3, 4, 5, 6, 7, right? So this is our 5/7 location. I'm going to mark the location of 7/8. 1, 2, 3, 4, 5, 6, 7. This is 7/8. I'm going to mark the location of 2/4. Just count over 2. 1, 2. Of course, out of 4. This is 2/4. 2/4, remember, same thing as a half. We are halfway between there. Mark the location of 1/4. Hopefully this is getting really easy by this point. Just marking 1 over there. Location of 8/8. 8/8 is the same thing as 1. Just going right here. There's your 8/8. Location of 2/6. Right there. There's 2/6. Remember 2/6 is the same